Today we are going to cover section 1.5, linear equations. So write down your title, be sure to write down your essential question. How do you solve equations using a graphing calculator? Paste your cutout or copy it down, and we have example number 1. Go and pause it, and we'll continue once you are ready. So linear equations in one variable. An equation is a statement that two expressions are equal. So therefore an equation is going to contain an equal sign. To solve an equation means to find all numbers that make the equation a true statement. Such numbers are called solutions or roots of the equations. So in Algebra 2 and Algebra 1, you guys been calling those solutions. As we graph them, we're going to also know that that is the root or the roots of the equation. A linear equation in the variable x is an equation that can be written in the following form, where ax plus b equal to 0, where a cannot be equal to 0. So that is the question. Why is a not equal to 0? So in this case, your x is your variable that has a coefficient of a. So therefore, if a is 0, that means that this term disappears and we no longer have a variable. But let's go and start with problem number 1. Let's go and solve the equation. And we need to check your answer. So solve for x, see what you get, and then we can compare our answers. Go and pause it. So in this case, we have an equation, and we notice that we have a x on both sides. We have an 3x on the left and a 5x on the right. I'm going to move my 5x to the left, so I'm going to move my x's to the left. That's a positive 5x. We can say negative 5x. Or if you want, you can do minus 5x and minus 5x. I'm going to move my constant to the right. It's a positive 1. We can say negative 1. Or you can do minus 1 and minus 1. I actually go through this process because it makes it a little faster as we go into more challenging problems. Negative 2x equals negative 8. Divide by negative 2 on both sides, so therefore x equals 4. And now I need to check my solution. So to solve an equation means to find all the numbers. In this case, x equal to 4 is only one number. That will make the equation a true statement. So therefore, when I plug in a 4 instead of the x on the original equation, that should give me a true statement once I simplify it. So I'm going to plug in 3 instead of the x. I'm going to replace it with a 1, with a 4 plus 1, 5 x minus 7. Instead of each of the x's, I'm going to replace it with a 4. And now I'm just going to simplify the left hand side, and I'm going to simplify the right hand side. So that gives me 12 plus 1 will give me 13. That gives me 20 minus 7 will give me 13. This makes into a true statement, which means that this is the correct solution. Go and solve letter B and see what you get. So in this case, go and pause it. So in this case, we have x's on both sides, but we have a more complex equation. I have parentheses, so the first thing I'm going to do, I'm going to use my distributive property to multiply it out. That gives me 10 plus 6x minus 12. I'm going to use my distributive property on the right hand side. I'm going to distribute the negative or the negative 1, however you want to think about it. So I'm just going to distribute the negative, gives me negative x minus 5. Before I start moving things left to right, or adding on both sides, I need to combine like terms. I need to simplify the left and simplify the right. I'm going to combine my terms, my constants. That gives me 6x minus 2. Combine like terms, negative x plus 12. And now that simplify on the left and on the right. I'm going to move my x to the left. We can say positive x. My 2 to the right, we can say positive 2. That gives me 7x equals 14. I'm going to divide by 7 on both sides, so therefore x equals 2. To check to make sure that this is the correct equation, this correct solution, I'm going to use substitution and I'm going to replace each of the x's to be a 2. Then it should also give me a true statement. Checking is a very quick process. 10 plus 3, 2. Instead of the x, I'm going to replace it with a 2 minus 4. Instead of the x, I'm going to replace it with a 2 plus 5. That gives me 10 plus 3. That gives me 4 minus 4 gives me 0. That gives me 7. 10 plus 0 is 10. 17 minus 7 is 10. So therefore, this also gives me a true statement, which means that this is the correct solution. If by any chance you got a false statement, then you know that you made a mistake above. Example number 2. Go and copy it down, and we'll start once you are ready. Go and pause it. So there's different ways to solve every single equation. As long as you do your steps properly, you'll end up with the correct solution. So what will be my process for this? One of the things I notice is that I have a fraction. So I'm going to get rid of my fractions. Now some people prefer to add both equations first, and you can both expressions. So you can add both fractions first if you want, but I prefer to just get rid of the fractions right away. So on my denominator, I have a 6 and a 2. So I'm going to multiply by the lowest common multiple. Lowest common multiple between 6 and 2 will be 6. So I'll multiply the left by 6 and the right by 6. I'm actually going to multiply both expressions by 6. Both fractions. So multiply each of the terms by 6. My 6 cancels out. So therefore I just have x plus 7. I'm going to reduce my 6 and my 2. Divide by 2 cancels out. This gives me a 3. So therefore I have plus 3 multiplied by 2x plus minus 8 equals negative 24. And now I can use my distributive property to simplify, combine like terms, and solve it. Go ahead and solve it, see what you get, and then we can compare our answers. Go and pause it. So in this case, I'm going to use my distributive property to multiply this out. That gives me x plus 7 plus 6x minus 24 equals negative 24. Before I start adding things on both sides, I'm going to combine like terms. So that gives me a 7x. 7 minus 24 gives me negative 17 equals negative 24. Plus 17 on both sides. Or I can just move this to the right because I say positive 17. That gives me 7x equals negative 7. So therefore x equals negative 1. And now I need to check my answer. To check my solution, I'm going to replace my x with a negative 1. So therefore I have x plus 7 over 6, so I'll be negative 1 plus 7 over 6 plus, instead of the x, I'm going to replace it with a negative 1. I'll be 2x, so 2 times negative 1 minus 8 over 2. And now I need to simplify, and that should give me a true statement. This is 6 divided by 6 gives me 1 plus. That is negative 2 minus 8 is negative 10 divided by 2 is negative 5. So that's -4 equals -4. So therefore, that gives me a true statement, which means that this is the correct solution. For letter B, how can I solve this equation? So now we have decimals. So when we have decimals, we can actually work through the decimals. And if you have a calculator, you can just work through the process. Now, if you don't have a calculator, the best thing to do is to get rid of the decimals. And actually, let me fix this here. This is just 0.4. So the best thing to do is to just get rid of the decimals. In this case, we have no decimals here. We have 2 decimals here, and we have 1 decimal here. So if you can fix that, it should be 0.4. I need to get rid of all the decimals, so therefore I'm going to get rid of 2 decimal places. So therefore I'm going to multiply by 100. The left and the right. I'm actually going to multiply each of the terms. I'm going to multiply the 2 by 100 and this term by 100. 100 times 2 will give me 200. Plus, when you multiply by 100, I'm going to move the decimal to the right twice. So it gives me 3. 5 minus x. When you multiply by 100, I'm going to move it to the right twice. So it gives me equals 40 times 5. And now that becomes a much easier equation to solve without a calculator. I'm going to simplify, so it gives me 200 distributive property, 15 minus x minus 3x equals 200. Whereas in this case, I can just subtract my 200 on both sides. So they cancel out. And you probably notice that I could have done that here as well. Might make it a little faster process. So that cancels out. That gives me 15 minus 3x equals 0. I still have my equal sign here. Move my 15 to the right, we can say negative 15. Divide by 3, so therefore x equal to positive 5. And now that I solved it, I can check my answer by just plugging it back in. So therefore I have 2 plus 0.03. Instead of the x, I'm going to replace it with a 5. That gives me 0, so therefore that becomes 0. So therefore I only have 2 equals 0.4 times 5 will be 2 as well. So therefore, this is the correct answer. So take the time to copy down your cutout or paste it. Go and pause it, and we'll continue once you're ready. Intersection of graphs, method of graphical solution. So to solve the equation f of x equals g of x graphically, so for example, if I was going to solve negative 2x plus 1 equals x minus 5, if we solve it on the left-hand side, if I have negative 2x plus 1 equals x minus 5, and I solve it, move my x's to the left, we can't say negative x. Move my 1 to the right, we can't say negative 1. That gives me a negative 3x equals negative 6. Divide by negative 3, x equals positive 2. We can solve it. But if I want to be able to verify graphically, if I want to check it algebraically, we can do what we did on example number 2 and just plug it in. If I want to be able to check it graphically, then f of x will be negative 2x plus 1, where that'll be its own function. And g of x, in this case, will be x minus 5. That'll be its own function. And if we graph those separately, then the x-coordinate of any point of intersection of the two graphs is the solution of the equation. So therefore, the x-coordinate of the point of intersection of the two graphs is the solution. So in this case, your solution was x equal to 2. If we graph the first one, which is here, and we graph the second one, which is here, then the intersection is going to be a point. In this case, the intersection is positive 2, negative 3. And the x value is the solution. And we use this quite a bit whenever we have an equation and we want to be able to find out what the solution is, then we can just do it graphically as well. Now, in general, if f and g are linear functions, then the graphs are lines that intersect at a single point, such as this equation. No point, there is no solution, or infinitely many points, and that's whenever you have the same equation. So therefore, if it has a one point of intersection, it has one solution, and we say that if it has one solution, it's going to be conditional. Your solution is conditional to x equals being 2. If you graph each of the functions and there's no intersection, notice that the slope is 2, but they have different y-intercepts, then there's no solution. That means that there's a contradiction, that there are no values that will make this a true statement. And if it happens to be the same equation on both sides, then that means that they're the same line. That means that we have an infinite number of solutions. The solutions are throughout the entire graph. Then that'll be a identity because one equals to another. Most of the time, we're going to write down as infinitely many solutions, or the solutions are from negative infinity all the way to positive infinity, or we also say all real numbers. So let's continue with example number 3. A and B. Solve and then check your solution graphically. Go and copy it down, pause it, and we'll start once you're ready. So go and solve the first one, see what you get. Pause it, and we can check our answers. Excellent. So in this case, I notice that I have parentheses, so I'm going to use my distributive property to simplify this out. That gives me a negative 2x minus 2 plus 6x equals negative 4. I'm going to combine my like terms. Positive 4x minus 2 equals negative 4. I'm going to add 2 on both sides, so I end up with 4x equals negative 2. Divide by 4, so therefore x equals, that gives me negative 2 divided by 4, which is negative 1/2. And now I'm going to check my answer graphically. So I'm going to use my TI-84, and I'm going to press y equals so that I can go into the equation. I'm going to type in the first equation. I want to make sure that I use my negative, not my minus. On the first, there's a negative 2 negative 2x. My x is here, not my times, but my x, my variable, minus 2, parentheses, 1 minus 3x. My second, y2, will be negative 4. Make sure that you use the negative and not the minus. And now I'm going to press enter, and I'm going to graph it by pressing graph. It's going to slowly graph each of the functions. And now I need to be able to find the intersection. Now notice that underneath the trace, there's a calc. It's in blue, so I'll press my second calc, and then I'll go down to intersect. So your graphing calculator can find your maximum, minimum, your zeros. I'm looking for my intersect. It's going to say first curve. It's going to be on the first curve, so I just press enter. Second curve, I'm going to just press enter. Guess, yes. And your intersection is at negative 0.05, comma 4. Notice that your x value is your solution. Now, most of the time I'll be using decimals because it's a little faster to use. So if you go into decimals.com, now you can sign in. I'm not going to graphing calculator. You can sign in, so that way you are able to save some of the graphs that we're going to be working with. And I'm going to type in y equals. I'm going to type in the first expression, which will be now my function. Now on the second line, I'm going to type in y equals negative 4. Negative 4. And now, sometimes I use decimals because it's a little faster to be able to see the solutions. So therefore, that is negative 0.5, comma negative 4 is the intersection. Your x value is the solution. Notice that it matches. I'm going to go ahead and graph it on my paper. So I'll make a 5x5 graph. 2, 4, 5, 2, 4, 5. And I can graph y equals negative 4. That is a to graph this, I'm just going to go back to my graph, and I know it crosses at 0, negative 2, 1, 2. And in here, you can actually just drag your point if you're not too sure. There. And 2, 6. Close enough. There you go. 2, 6. So therefore, I can just go back and just create a quick graph. It doesn't have to be perfect. You do want to make sure that you use a ruler when you are graphing for my class and for your homework. And now according to this, your intersection is here. The point of intersection is negative 0.5 comma 4, negative 4. And your x value corresponds to your solution, the x value of the intersection. Let's try letter B. Go and solve it and see what you get, and we'll compare answers. Go and pause it. So in this case, I'm going to use my distributive property to multiply this out. That gives me negative 2x minus 4 equals 2x minus 4. And at this point, you'll notice that they're equal to each other. So at this point, you should be able to notice, identify that that's an identity. But let's say you kind of did not notice and you minus 2x's on both sides. If by any chance your x's cancel out, you have negative 4 equals negative 4. If your x's cancel out, it's going to be either a contradiction or an identity. Is this a true or false statement? That is true, so therefore it's going to be an identity. Or if by any chance you continue and say, plus 4 on both sides, you end up with 0 equal to 0. That's a true statement. So you have infinitely many solutions. Or we can say from negative infinity all the way to positive infinity. That'll be in interval notation. Now, let me go and graph it. I'm going to make a 5x5 graph. 2x minus 4, negative 4, up to the right 1. And in this case, we know that at this point that the graphs are exactly the same. So we have an infinite number of intersections. We have an infinite number of solutions. The solutions are from negative infinity to positive infinity, or we can say all real numbers. Now, if we actually take the time to graph it on Desmos, or your graphing calculator, whichever you prefer, we have y equals 2x minus 4, y equals 2 parentheses x minus 2. We're going to turn them off and on. And actually, I can go back and change the color by holding on to it to red. Let me change this one to blue. So notice that if I turn the red one off, they are overlapping, and we can confirm that because that one disappears. And we use this quite a bit. Sometimes whenever we have an equation and we want to find out how many solutions does it have. So if you have the sine of x and y equal to 3. So if you have that equation, we know that there's no intersection, there's no solution for a solution sine of x equal to 3 because there's no intersection. If it was equal to 0.5, then we can find all the intersections, all the solutions in there. But for now, let's continue to example number 4. Go and copy it down. You cut out example number 4. Go and pause it, and we'll continue once you're ready. So in this case, we are using the x-intercept method of graphical solution. So to solve an equation such as f of x equals g of x, then we can just graph this and find that the x-coordinate of any x-intercept of the graph of f of x is a solution of the equation. Notice that if we think about moving your g of x to the left, becomes a negative. So where this is your f of x, your g of x can move to the left, so becomes a negative g of x. That's the new function. Then the x-coordinate of the x-intercept is going to be the solution. So in this case, the x-coordinate, now the intersection of the x-intercept is a solution for the equation. So let's go and solve example number 4a. We need to solve it, then we're going to check their solution. To solve it, we're going to move the 1 to the right, becomes a negative 1. So therefore, we have 3x equals 3. Divide by 3, x equals 1. Now, to check our solution algebraically, I can plug in the 1 in here and check algebraically. To check the solution using the x-intercept method, I need to move my 4 to the left. So therefore, I'm going to have 3x plus 1. Move my 4 to the left, you can say negative 4 equal to 0. Where this is your f of x, stay the same. And your g of x can move to the left. And that's where they have this notation here. So therefore, if I use my Desmos or my graphing calculator, and I just type in y equals 3x plus 1 minus 4, or I can simplify that, then my x-intercept, the x-coordinate of my x-intercept is my solution, which is 1, which matches my answer here. So let's go and make a quick x and y axis. We're going to do a 5 by 5. Make sure that you guys are using a ruler. Then I'm going to graph this function here. Y-intercept is -3 once I combine like terms. My slope is up 3 to the right 1. Then using the x-intercept method, my x-intercept is here, which is 1, 0, and the x value. Most of the time we prefer to use the other method. Most of the time we prefer to use y equal to 3x plus 1 and y equal to 4, and then find the intersection. But this one works as well, and we'll be using that later on in the year. Letter B. To solve it, move my 1 to the right, becomes a -1. So it gives me 3 over 2x equals to 3. You can do two things. You can multiply by the reciprocal or multiply by 2 and then divide by 3. It's going to multiply by the reciprocal, which is 2/3. The 3's cancel, my 2's cancel, so therefore x equals, I'm going to cancel my 3's, so x equals to 2. I need to check my solution using the x-intercept method. So therefore, I'm going to move my 4 to the left, becomes a 3 over 2x plus 1 minus 4 equal to 0. And now I'm going to graph it. I can use decimals to graph it as well. In this case, simplify this gives me -3. My slope is up 3 to the right 2. And according to this, my x-intercept is 2, 0, and my x value is my solution. So you need to be able to have a good understanding in the class that we can graph each one separately. And when you graph each one separately, this is the first one. This is the second one. That the x value of the interception is your solution, or that if we just move the 4 to the left, make it equal to 0, then if we graph here, the x-intercept, the x value of the x-intercept is your solution. Let's continue to example number 5. Go and take the time to copy it down, and we'll start once you are ready. Go and pause it. Now, given f of x, which is this line here, and g of x, which is this line here, find the values of x such as f of x equals to g of x. Now, if you notice on the left-hand side, I have a few reminders for myself. These questions will be on the tests, and many of you guys will get these questions wrong. So you guys have a difficult time understanding your function notation, especially once we go into this type of problems that you've seen back in Algebra 1, Algebra 2, and once again in pre-calculus honors. And I need to use interval notation for some of my answers. So we have two functions, f of x and g of x. I want to find out when the values of f of x is equal to the values of g of x. And for this, you need to be able to have a good understanding that whenever we talk about f of x, that are the y values of the function. So this is the graph. So the y value, f of x equal to 5 right now. 4, 3, 2, 1, 0. The y values are f of x. Whenever we're talking about g of x, those are the y values for g of x. So if we go from left to right, that is -3, -2, -1, 0, 1, 2, 3, 4. and so on. And that's why many times you guys will see this notation on your SATs and on the textbook. Y equals to f of x and y equals to g of x. But you need to understand that f of x is your y values for the f function, and g of x are the y values for the g function. And when you connect all of them, you get the graphs. So when are they equal to each other? So if I think about what is the value of x that they're equal to each other. So if I think about here, when x equal to -3, the y value is 5 for f of x, and for g of x is -1. If I go over to the next point, the y value is 3 and that is 0, so they're not equal. Now to get to this point is when the y values are the same. So the y values are here, are the same, so therefore when x is equal to -1, we're looking for the x values. The y value is 1 for both, but we're looking for the value or values of x. F of x minus g of x equal to 0. So when I subtract the f of x value and the g of x value, it gives me 0. What is the value of x when x is equal to? So if I think over, let's start with this point here. I can start actually here. The y value for f of x is -5, and the y value for g of x is 4. So -5 minus 4 gives me -9. I need it to be 0. The y value for f of x is -3, and the y value is +3. So -3 minus 3 is -6. So therefore, they are not going to cancel each other until they are here. The y value is 1, and the y value is also 1. 1 minus 1 is 0. So therefore, this is also when x equal to -1. And one of the things that you need to be able to realize is that those two expressions are the same. So if you move your g of x to the left, just like we talked about before, above, that gives you this expression here. Do you guys agree? Excellent. So now, see if you can identify the values when f of x is greater than g of x. When does that happen? Go and pause it, think about it, and then write it down. So when is f of x greater than g of x? So if you think about f of x, if we start here, the y value is 5, and the g value is -1. So that is correct. F of x is bigger than g of x. Even if you go over here, the y value for f of x will be 8, 10, and for g of x is -3. So when does it stop being greater than? It stops being greater than here. All of those values, the f of x is bigger. Do you guys agree? So therefore, for all the values from up to there, up to -1. So from -infinity all the way up to -1, the f of x values are larger than the g of x value. And we're going to write down as a set notation, or interval notation. Is from -infinity all the way to -1. The question is this parenthesis or bracket? Because there's no equal sign, it's going to be parenthesis. Letter D. When is g of x less than 3? Well, g of x, we're just talking about this graph here. The y value is -3, -2, -1, 0, 1, 2, 3. Once we go further, the y value is greater than 3. I want it to be less than 3. So therefore, it's going to be less than 3 any point over here. But we're looking for that domain. So 1 from -1 all the way up to from negative infinity all the way up to 1. From negative infinity all the way up to positive 1. The question is, does it have a parenthesis or bracket? It has a parenthesis. And let's make this an equal sign underneath. So if you can change that to less than or equal to, then that should be actually greater than or equal to. So let's go and fix it because it was the same as letter D. So that should be greater than or equal to 3. So when are the values of g of x greater than or equal to 3? Well, then that will be in this part of the graph, correct? That is 3, 4, 5, 6, and so on. So therefore, will be the domain will be from 1 all the way to positive infinity. So from 1 to positive infinity. And I made a mistake. What is the mistake that I made? Correct, because of the equal sign, that means that it can also be equal to 3. That means that we're also going to include the number 1. So therefore, this one gets a bracket. So you think you got this? So let's see. See if you can do example number 6 all by yourselves, and then we can compare the answers. Go ahead and pause it. Start on example number 6, and then we'll compare. You got it? So therefore, we have f of x is this graph here, is an absolute value facing up, and g of x is another absolute value facing down. I need to be able to find the values when f of x is equal to g of x. Well, when are they equal to each other? The y value is -1 here for both here and here. That's where they cross. So therefore, we'll be at -1 and 1, 2, 3, 4, 5. Remember that you're looking for the values, all values of x. And we're going to place it as a set notation. So whenever you have two values, you can do two things. You can say when x equal to -1, or when x is equal to 5. Or we can also say when x is equal to, and we're going to place a brace, -1, 5. Both answers will be correct. Don't get this confused with the interval notation. These are just two specific values. B. When is f of x less than g of x? Well, let's look at the values. We want the f of x to be smaller. Right now, if we start from the left, the f of x is 3, the g of x is -5. F of x is bigger. We want it to be smaller. Here the same. So after here, that's when the g of x becomes bigger and the f of x becomes smaller. So it's going to be from here, from -1 all the way up to 5. Once you get further than 5, f of x becomes bigger again and g of x becomes smaller. And you want f of x to be smaller. So for this one here, for letter B, it will be from -5 all the way up to 5. And we're going to write down in interval notation. What's it? In interval notation. And now we have from -1 all the way up to 5. And there's no equal sign, so they both get parentheses. So from the interval from -5 all the way up to 5. Now, letter C. When is f of x greater than g of x? Well, when is f of x greater is from here all the way up to when they become equal, which is here. Then f of x becomes smaller and becomes bigger once it gets over here. So therefore, that will be from -infinity all the way up to -1, and from 5 all the way up. And that'll be for letter C. So that'll be from -infinity all the way up to -1, get parentheses, and then we'll continue with 5 all the way up to positive infinity. And remember, in between it'll be a union. When is f of x greater than -2? Well, when is f of x greater than -2? F of x is 3, 2, 1, 0, -1, -2. So all this section here, so in this section, this is -2 for the y value. That section here, and this section here. That is the section where f of x is greater than -2, and we want to be able to write down the interval of the x-axis of the domain. So it'll be from -infinity all the way up to 0, 9 including 0, so it gets parentheses. If there was an equal sign, then it will be a bracket, union, and then we'll continue from 2 all the way to positive infinity. And the last one, when is f of x minus g of x equal to 0? Well, you have to recognize that's the same as letter A. So therefore, when they intersect, is the only time that they're going to be f of x minus g of x will give you 0. So that will be, that's set from -1 comma 5, only those two values. So make sure to write down your summary, and I'll see you guys next time.